Okay, so we're going to be doing a mathematical induction proof. Alright, and the sequence we're going to prove is 7 plus 14 plus 21 all the way up to 7n equals n times 7n plus 7 over 2. So our first step is called the basis step, and we're going to prove that in the simplest case, our left-hand side equals our right-hand side. So we're going to take the first term of this sequence, which is 7, and set it equal to the right-hand side, n times 7n plus 7 over 2, and see if it works when n is equal to 1. So we're going to plug in 1 for n and get 7 times 1 plus 7, which is 14, times 1, 14, and divide that by 2, which is 7, so it checks out, and that means that we can continue on with our proof. So next thing we're going to do is we're actually going to just assume that n is equal to k, and we're going to substitute k in for n. And so we're going to end up with 7 plus 14 plus 21 all the way up to 7k equals k times 7k plus 7 over 2. Okay, so now what we're going to do is that we know the equation works for k. We want to make sure that it works for the rest of the numbers in our sequence. So to do that, we're going to look at the next term by setting n equal to k plus 1. So when we set up our new equation, we're going to have 7 plus 14 plus 21 all the way up to 7k, although this time we're going to add 7 times k plus 1, so that we can check to see if the next terms in the sequence also work for this proof. And so we're going to end up with 7 plus 14 plus 21 all the way up to 7k plus 7 times k plus 1 equals k plus 1 times 7 times k plus 1 plus 7 over 2. Okay, so another important thing to note is that earlier on we proved that this first part of the equation is equal to, when we substituted in k, we proved that this part of the equation is equal to k times 7k plus 7 over 2. So when we set up our new equation, instead of writing out this whole piece right here, we're going to substitute that in because it's much easier to work with, and we know that it's true. So we have k times 7k plus 7 over 2 plus 7k plus 7, because we originally had that term at 7 times k plus 1, but we're going to distribute the 7. And then on the right-hand side of the equation, we have k plus 1 times 7k plus 7 plus 7. Again, we distributed the 7 out to 7 times k plus 1. And all that is going to be over 2 as well. Okay, so working on the left-hand side, what we're going to do is we're going to distribute the k for this term here, and we're going to end up with 7k squared plus 7k over 2. And then we want to add these together, so what we're going to have to do is make a lowest common denominator. And we can do that by multiplying these top two terms by 2 so that we can put this whole equation, or this whole part of the equation over 2, so that it adds in nicely with this part. So this was originally 7k plus 7. We're going to multiply both those terms by 2 and get 14k plus 14 over 2. So then we're going to look at the right-hand side, and here we're going to combine like terms. So it becomes, instead of 7k plus 7 plus 7, we have 7k plus 14. These become two binomials, which we will later on FOIL. Okay? Okay, so this part is going to be important. Now that we have those two lowest common denominators, we can add those two terms together, and we end up with a trinomial of 7k squared plus 21k plus 14 over 2. And then on the right-hand side, we're going to have, after we FOIL, we're going to have 7k squared plus 14k plus 7k plus 14 over 2. And then when we combine like terms, we get 7k squared plus 21k plus 14 over 2, which is going to be the same as what we ended up with on the left-hand side, and we can't simplify these any further. So we know that this proof is correct and that our original sequence is true. Thank you.